Firstly, I'd like to say welcome to this session of the Open Science Conference for SCAR. The session is on human impacts on Antarctica. And I am Kevin Hughes from the British Antarctic Survey, and I am one of the co-conveners of the session, along with Jasmine Lee, also currently at the British Antarctic Survey, and Andrew Lowther from the North Polar Institute, who has a lovely elephant seal, is it, behind you? Very, very fetching. So we are co-leaders of research theme 2, which is on human impacts and sustainability, which is part of the ICON scientific research program. And that stands for Integrated Science to Inform Antarctic and Southern Ocean Conservation. So we are hosting this session as part of that research program, part of the work that we're doing with that. And I would just like to encourage you all to look at that, look at the research themes objectives on the SCAR website, and please do sign up to Anticon if you have an interest in that sort of work. We look forward to interacting with you. So just a few housekeeping notes. We have a little bit of time at the end of each talk, I hope, for some questions and answers. So if you have any questions, please put them in the question and answer facility on the screen, so we can read those out and get some good answers, I hope. I would also like to remind you that if you're giving a presentation and you don't want it to be put onto the YouTube videos, you need to inform the organizers of the sessions by the 12th of August to opt out. So just please be aware of that. And finally, just to say that we have got some really excellent e-posters available. So I would strongly recommend that you pop along to click the tab on your computer, have a look at those. We've got posters on wildlife and microplastics, on persistent organic pollutants, black carbon, phosphorus pollution, plastics within protected areas, and metal pollution, amongst other things. So really worth a look. So I would strongly encourage you to please go along and have a look at that. So without any more ado, I would like to introduce our first speaker. We have Anton van de Putte from the Royal Belgian Institute for Natural Sciences, and he's going to talk to us about the UN Ocean Decade, I think. Over to you, please, Anton.
I'll try to get this to work without messing it up too much. Andy knows I'm really bad at this. Okay, yes, so I'm going to talk about the Southern Ocean contribution to the UN Ocean Decade. This was submitted by Annemie Janssen, but she's now doing fieldwork for a PhD, so I have the honor of presenting this, but this is really a work of many people, so I would like to underline that. First, taking a bit of a step back, what is the United Nations Decade of Ocean Sciences for Sustainable Development? United Nations developed this vision for the period of 2021 to 2030, that we work towards the science we need for the ocean that we want. And the mission of that is to develop transformative ocean science solutions for sustainable development, connecting people and our ocean. And that work has been developed looking at 7 ocean decade outcomes that will work towards this ocean that we want, which is a clean ocean, a healthy and resilient ocean, a sustainable harvested ocean, a predictable ocean, a safe ocean, a transparent and accessible ocean, which is mostly in terms of data, and an inspiring and engaging ocean. So these are 7 outcomes of the decade globally that the decade globally wants to work towards. In terms of governments, I'm going to not go in too much detail into this, but you have the Antarctic Treaty System and you have the United Nations system. And actually, the treaty system predates that of the UN. So you sort of have 2 governing systems that live in parallel. with neither one having anything to say about the other ones, but it is probably wise to listen to each other, because as you see from this Pilhausen map, what happens in the Southern Ocean doesn't stay in the Southern Ocean, and equally what happens in the rest of the world doesn't stay there either. So there is a need for a dialogue, and this is also why this work was being set up, is that we, from the Southern Ocean perspective, can inform the UN decade of the priorities that we see as a Southern Ocean community. This work started back in February 2020, and the idea from the start was to try and engage a lot of different stakeholders, scientists and industry, national programs. So we really wanted to engage a wide group of stakeholders in order to have something in the action plan which would make sense for many, or from as many as we could. February 2020, there was a relatively small workshop that was organized as part of the Ocean Sciences meeting in San Diego, where a small group of people looked at priorities for some of these ocean outcomes. This was, I think, one of the last workshops that took place before COVID hit. But through the COVID period, we developed a task force with a number of organizations that expressed interest to work towards this. This was coordinated by SCAR with input from many other different organizations that started working towards these goals. The first thing that we did was develop a review of identified priorities for the Southern Ocean in the context of the UN Ocean Decade. So for this, we looked at various implementation plans of the different partner organizations, like SCAR, SCORE, SUSE, ICED, the climate program of WMO, European Polar Board. And we looked at what are the priorities that these organizations have already written down and defined. And of course, an important aspect here as well was the SCAR Horizon Scan, which was published in 2016, which is still a very important guidance for what we need to do in the Southern Ocean. So this review was published, and then there was a survey where we asked people around the world to comment on this review, to add items that we might have missed, and to rank the items that we had listed in order to get a better sense of these priorities. Then we developed a number of working groups according to these different ocean decadal outcomes, where we had working group leaders from academia, government, or industry. And again, engagement was open to all. Anybody at any stage could comment on the documents that were shared online. In July, September, we had an output of individual working group reports where these priorities were synthesized, and these were also synthesized in a number of videos which were hosted on our website. And what we already see during this step of the process is that these 7 outcomes are not enough. Then in September, the idea was to have an in-person event where we could engage and discuss the outcomes of the different working groups. This was, in the end, an online event where we had more than 400 participants engaging again in reviewing the steps that we had taken so far. Then September, December 2021, we wrote up the Southern Ocean Action Plan, and this action plan was published early April of this year. So normally, Andy should be able to share a link for that in the chat. But like I said, a key outcome was there's 5 really cross-cutting themes, and I'm going to highlight them here in the talk. For the other ones, I recommend that you read the document. Funding, of course, as always, is key. For what we do in the Southern Ocean, we really need sustained and long-term investment in what we do, the research, the observations, and that is key. The short-term financing, a lot of things, is not going to work very well. There are specific constraints linked to the Southern Ocean. We operate and need to observe in very inaccessible areas, and we need to do that year-round, so that's not cheap. And equally, we need to transport preserved and rapidly analyze samples from those regions. Again, it's not cheap. And so really we need to establish a sustained collaborative network of long-term observations. There is a diversity of funding, which means that there's money around, but it's in many different places, and it's not always as coordinated as it could be. We need to cross boundaries. We need to cross national and regional boundaries and enforce collaboration at that level. We also need to link more between disciplines. At a more global level, we need to co-design global priorities with our northern counterparts from the Arctic in order to translate these messages to the global community. Then we have identifying and connecting stakeholders. We need to improve the dialogue at the science policy interface. And again, within our own community for the Southern Ocean, these are fairly well developed, but the crux here is to translate these to a global level and to ensure that these priorities that we see for the Southern Ocean are also recognized at a global level. Important tools that can help with this, these sort of development of decision support tools like the Antarctic environment portals are probably key in promoting this. We need to ensure that we integrate social needs and reflect and address these through the research, which is often lacking in the way we engage with research currently. And there's a strong need to link the industry with research infrastructure and logistics so that we can co-develop communication and data collection platforms and in the end, better management practices. My, how you call it, hot topic, data observations and modeling. I'm a data manager by trade, and it's clear we need to further improve the spatial and temporal coverage of our observations. We need to ensure that data and information are fully utilized. And this means that we need to work according to the FAIR principles so that data is findable, accessible, interoperable, reusable, and also to encourage open science so that it's not just the data that is shared, but also the code and the tools for doing research. Again, long-term sustainability for observations and data stewardships. The observations we make are so valuable that we cannot, we cannot lose them. We need to conserve them and make optimal use of them. Within the Southern Ocean, there's always going to be data gaps. So modeling, various types of modeling will always play an important role. Then we have diversity and capacity building. We need to ensure that there's a diversity of voices at the table at all stages. There is not enough capacity globally to do the tasks that we want to do, and it's very unequally distributed. Again, open access can help to these things by making technology and tools more accessible globally, so that also in other countries that have less resources that they can engage in these processes. And so we make this more democratic. Where are we now? Again, like I said before, we need to engage the UN Ocean Decade and to bring our priorities to the table there. In June, we had the UN Oceans Conference in Lisbon. We had a number of events there with participants like the foundation, Prince Albert from Monaco Foundation was there, and they were engaging. But this should and needs to be strengthened even more. So that's my brief overview of where we currently are with the Southern Ocean Decade Action Plan. I want to thank the Belgian Science Policy for providing funding for this work, the European Polar Board for hosting the website, the Decade and the Polar Data Forum Week, various webinars, NEOS in the Netherlands for the technical support during the meetings that we had, and of course all the chairs and Southern Ocean Task Force contact points for working together with us. And again, a lot of thanks to Annemie. I want to make sure that if you see her anywhere in the world that you can recognize her. She's done a tremendous job, and I want to thank her again. So thank you, and I'm happy to answer any questions.
Well, thank you very much, Anton. I think that was an excellent talk. clearly it's a huge task and a huge program covering many different areas. I'm just wondering, Andy, do we have any questions in the question answer? No. Maybe I could just ask a quick question. Earlier in the presentation, you talked about this relationship between the UN and the Antarctic Treaty System, and I think, as you said, there's a clear line where one part UN does the bit up here and Antarctic Treaty does the bit on the very bottom of the world. But I'm wondering what sort of engagement or what sort of communication between those two bodies have you got planned to try and bring this more integrated approach forward so that we all benefit?
I think this is at different levels. I think we're also in the process of trying to define that. What is the best way to engage that? I think if you look at the UN decade, there's a number of technical platforms that would be used. And I think for these, it would be fairly simple. It would be best that we use similar platforms and similar standards so that can be exchanged. But these are practical solutions. And I think otherwise, I think there's a number of member nations of the Antarctic Treaty System. And ideally, it would be, I think, for the policy members of these countries, that they take the messages that they understand that are important, or that we can tell them that are important, that they take that up into this global context. But I think that's something in the next months for us to work on and further improve. And if people are interested or happy to help with that, they're welcome to join the effort.
Great, thank you very much. I think it'll be interesting to see how that develops in the future, and I think it's great that steps are being taken to try and bring those two bodies together in a useful way. I think if there's no other questions in the question answers, perhaps we might move on to the next speaker. Now, we have a pre-recorded talk ahead of us, and this is by Pablo Tejedo, who's from the University Autónoma de Madrid. And this is about tourism in Antarctica. Now, I do believe that we might possibly have some of the co-authors in the audience. So they might, if there are questions, they might be able to provide some answers in the comments box below the question. I don't know if they're there, but if they are, please feel free to try and provide some comments and answers to any questions that might go in, because I think this is an extremely important topic, and yes, I shall look forward to hearing what Pablo has to say. So can you run the talk, please?
Hello everyone. If you are seeing this recorded presentation, it's because I'm flying right now, coming back from La Palma Island, Spain. I have 1 week of field work for a research project. Therefore, I cannot do this oral presentation in live. First of all, I want to thank the organization for this opportunity. Kevin, Jasmine, and Andrew have done a great job to organize this session about human impacts on Antarctica. The title of this presentation is Unveiling the Real and Potential Environmental Impacts of Antarctic Tourism through a Comprehensive Meta-Analysis of the Published Research. In summary, I'm going to present the results of an investigation that led to a paper published this year in the Journal of Environmental Management. And this is me, Pablo Tejedo. I work at the Universidad Autónoma de Madrid, specifically in the Department of Ecology. I work on Antarctica since 2008, mainly in human impacts, such as soil conservation, non-native species,
Do you have a problem with the sound? I'm sorry. Still don't hear anything. Hopefully we can get our IT problems sorted out. I think we've got a little.
Sorry about that. Just give me a minute.
Thank you very much.
Hello everyone. If you are seeing this recorded presentation, it's because I'm flying right now, coming back from La Palma Island, Spain. I have 1 week of field work for a research project. Therefore, I cannot do this oral presentation in live. First of all, I want to thank the organization for this opportunity. Kevin, Jasmine, and Andrew have done a great job to organize this session about human impacts on Antarctica. The title of this presentation is Unveiling the Real and Potential Environmental Impacts of Antarctic Tourism through a Comprehensive Meta-Analysis of the Published Research. In summary, I'm going to present the results of an investigation that led to a paper published this year in the Journal of Environmental Management. And this is me, Pablo Tejedo. I work at the Universidad Autónoma de Madrid, specifically in the Department of Ecology. I work on Antarctica since 2008, mainly in human impacts, such as soil conservation, non-native species, or pollutants. This is the structure of the presentation. As I have only 10 minutes, I will focus on some concrete topics and results that are more important regarding the environmental impacts of Antarctic tourism. I'm giving this speech, but I'm really representing a research team. These are the co-authors of the paper. Only thanks to all of them, it was possible to carry out the article and synthesize a large amount of information in a coherent way. I guess we all know more or less about the evolution of Antarctic tourism. We have a growth in numbers, an extension of tourism season, and a diversification of activities. Tourism is especially and temporally concentrated, and mostly shipborne. Tourism is regulated in a complex way, mixing regulatory mechanisms from the Antarctic Treaty System, self-regulation throughout IATO bylaws, and even other international regulations such as those by the International Maritime Organization. The Antarctic scientific community is concerned about the environmental impacts resulting from the presence of these visitors and has been conducting studies of these topics for years. The aim of our study was to update the current knowledge of the environmental impacts resulting from the Antarctic tourism by undertaking a meta-analysis of scientific publications addressing the following set of research questions. First one, what adverse environmental impacts are being associated with Antarctic tourism operations? What research methods have been adopted to assess the negative consequences of the presence of tourists in the Antarctic? How can the results obtained be applied to improve Antarctic tourism management by the Antarctic Treaty System? This bibliometric meta-analysis follows the guidelines on preferred reporting items for systematic reviews and meta-analysis. This approach divides a structured assessment of publications into 4 distinct phases: identification, screening, eligibility, and include works. In this study, a 5th step was added involving an in-depth content analysis of the selected works to this approach. In this slide, it's important understanding that we have two sets of records. Types 2A and 2B are about different topics related to Antarctic tourism, but not focused on environmental impacts. Types 3A, 3B, and 3C are specifically focused on environmental impacts in Antarctica. The first group includes publication about those impacts produced by global pollutants. The second group includes publications about local impacts, and type 3C are reviews. It is impossible to summarize all the results in 10 minutes, so I will present only some selected key ideas. The first one is the growing interest in this topic, with a positive trend in publications for all the types of publications for the last years. There are many potential impacts associated with tourism activities in Antarctica. Here, a concept board that we will try to identify all of them. When we did this figure, we found many impacts, but many are potential until proved otherwise. Tourism has both positive and negative consequences. Tourists as Antarctic ambassadors, citizen science, or science support are some positive aspects of this industry. A third of the reviewed in deep papers do not identify an impact as direct result of the tourist presence or activity. This should be valued positively. Almost everyone acts like a tourist at one moment or another in Antarctica, so it is difficult to assign impacts specifically to tourism. Here I'm doing a break during field work. All of us will have similar photos, at least I hope it. And we have local, regional and global impacts, and it's complicated to separate them. These studies are not always robust. More statistics and better designs are necessary. The use of approaches from other disciplines, such as the environmental impact assessment, could help in this task. We can apply impact control studies or before and after studies. There are many case studies developed in some locations, but less regional or global studies. And also there are few medium or long-term studies. And finally, it is difficult dealing with the accumulated effect of different impacts. Even in practice, it's almost impossible to discriminate if an impact is produced by tourism or by other human activities. We need more research on cumulative impacts and the interaction between impacts and different global drivers of change. This paper supports the working paper number 22 in the last Antarctic Treaty consultative meeting held in Berlin. This working paper, submitted by Spain, Ecuador and United States, proposed, first, that the parties promote the establishment of monitoring programs to assess the actual impacts arising from tourism activities. Second, that the Committee for Environmental Protection promote the development of these monitoring programs and continue with its work to understand the cumulative impacts of tourism on the environment. Third, that monitoring programs involve multiple stakeholders, including bodies such as SCAR, COMNAM, and IATO. The paper was well received by the parties. We hope that this initiative will continue in the coming years with more concrete actions and decisions. Our paper is also considered as a contribution to the AC21 project. This research aims to establish a collaborative network to develop a research agenda for Antarctic tourism. It is funded by the Academic Consortium for the 21st Century, and it will end in September. Among the objectives of this project are build a collaborative research network, facilitate short-term collaborations, and develop a research agenda through community participation. Our research team considered that one of the needs to adequately meet these objectives was to update the knowledge on the environmental impacts of Antarctic tourism. That is the main contribution of the paper to this project. The end point of our research usually is the starting point for new research questions. In this case, we are thinking in two new papers. The first one, a comparison between environmental impacts of Antarctic tourism versus environmental impacts of Arctic tourism. In this case, the focus of the paper could be opened by including the successful indicators applied in both cases. The second one, an assessment about how the scientific papers can contribute to the Antarctic management. The main objective would be to identify which working papers and information papers are supported by scientific articles, as in the case of the working paper 22 that was presented before. And some final remarks. Deal with environmental impacts of Antarctic tourism is not an easy task. We need implementing long-term monitoring. A regional strategical planning is also necessary. This is the main conclusion of our paper. The third final remark is basic. You need partners. Collaborative science is more productive and it helps to face the logistical limitations typical in Antarctica. And finally, money. Funding through specific grants or calls is possible to achieve small advances, but a permanent source of financing is needed. The application of an eco-tax has been proposed repeatedly and there are parties that support that idea. But it's not clear which institution should manage that money and how using this for tourism impacts monitoring. Okay, I think that was all I wanted to show you today. If you have any questions, you can contact me in this email. Thank you very much for your attention and enjoy the conference. Bye bye.
I think there were some extremely clear messages that came out from that presentation. I think there are predictions of up to 100,000 tourists visiting Antarctica next season. And I think it's pretty clear that we do need some better monitoring, as we do for all human activities in Antarctica. Is there a question from Krista there, I see?
Yes, unless there's other questions, I didn't see, I can't type in the chat as a panelist or the Q&A. So I guess I have a question for the co-authors. That was a really great talk. I was wondering if the paper identified any, like actually quantified the positive impacts associated with tourism. Like, can you identify positive behavioral change of the tourists that actually went down? Like, you know, if they go back and reduce their greenhouse gas emissions or, you know, get involved in local ocean conservation efforts. Like, I guess in summary, you know, like, can you quantify whether it's like worth it from like a climate change conservation standpoint to send people to Antarctica as tourists?
That is an excellent question, and I hope Daniela might be able to provide some response or thoughts on that. Jasmine, do you want to say something?
Yeah, we may even be able to unmute Daniela if she wants to talk. Hang on.
We've got a minute or two, so that would be fantastic if it was possible.
Hello.
I just allowed
Can you
you to
hear
talk,
me?
Daniela. Yep, we can.
Hi. Thank you, Jasmine, and thank you, Kevin, and thank you for that excellent question, Christy. Well, actually, when Paulo was explaining, we have like different articles in which we classified some from a social perspective, in which we were analyzing also behaviors and changes produced by the Antarctic experience. We did a specific emphasis on those environmental aspects in this paper. However, we are really interested in trying to quantify and in this way all these positive behavioral changes that we have and that has been just a little studied in the Antarctic. So we found some papers related to this. We are also doing some research on this, but we cannot say for sure how long these positive behaviors are lasting on visitors. That is one of the main questions we want to answer. We also want to explore a little bit more about ambassadorship, that we all know is an important issue for the Antarctic experience. However, we do recognize the importance of these behaviors and the ambassadorship effect, but we want to explore a little bit more, especially how long this lasts, because we can say that we have these positive impacts, yes, but we are not really sure how long is this once they arrive home. So this is an excellent question, and we want to follow up on this. Thank you.
Thank you, Daniela.
That's excellent. Thank you so much. And I'm glad we were able to get that through. That was wonderful. I think we need to move on to the next talk now. And again, this is another pre-recorded talk by Christina Saunders, who's from the Australian Nuclear Science and Technology Organization. And interestingly, something we don't really hear a lot about, she's going to talk about first evidence of atmospheric nuclear weapons testing fallout on a Southern Ocean island. So if that talk could be run, that would be fantastic. Thank you very much.
Well, thank you for the opportunity to speak in this session. I'm sorry that I can't deliver it in person, but I wasn't able to join today. This presentation is about some recent work that we've been doing, looking for evidence of atmospheric nuclear weapons testing in the sub-Antarctic. And it's being done in collaboration between the Australian Nuclear Science and Technology Organisation, British Antarctic Survey, the Universities of Tasmania and Bern, Securing Antarctica's Environmental Future Program, as well as logistical support from the Australian Antarctic Program. So as we all know, human impacts occur throughout the Antarctic region. So far, studies usually focus on what we can see, such as invasive species or the impacts of scientific research stations or tourism. However, there are many invisible contaminants, particularly those transported by the atmosphere and ocean over long distances. Previous work has looked at heavy metals, fossil fuel combustion sources, microplastics, pesticides, and they've been found throughout the region, whether in ice-covered or ice-free areas, abiotic or biotic systems. Almost all of these studies have been based on modern surveys, yet understanding the history, types and amounts of contaminants is important for establishing baselines, as this allows assessments of changes over time, particularly when it comes to understanding the combined effects of human actions globally and the release of contaminants into the ocean and atmosphere, as well as climate change, which is altering the potential pathways for contaminants to reach the Antarctic region. One rarely looked at type of contaminant come from atmospheric nuclear weapons tests. These occurred between 1945 and 1980 around the world by various nations, as you can see from this map, where it's coloured by nation, and also the size of the dot illustrates the total yield in each location. Most of the radionuclides have got long-lived half-lives. So just by example, plutonium-239 has a half-life of over 24,000 years, which means that more than 99% of it is still in the environment today. 90% of all tests were conducted in the Northern Hemisphere. However, 30% of the fallout inventory is in the Southern Hemisphere. And this is because of the number of high-yield tests conducted near the equator and in the Northern Hemisphere, which reached the stratosphere and were therefore distributed globally. We can look at different isotopes of anthropogenic radionuclides and their ratios to indicate where they've actually come from. In other cases, this is used to study atmospheric aerosols and their transport throughout the troposphere and the stratosphere, where different tests, the high yield ones reach the stratosphere, but the low yield ones only make it as far as the troposphere, and therefore fallout was local and or regional. Similarly, these radionuclides can be used as traces for biogeochemical, vertical and horizontal transport processes in the ocean, as well as a dating tool for paleo studies looking at changes in the 20th century. So there has been some work in Antarctica, not in the sub-Antarctic, but all previous work in ice-free Antarctica is based on modern surveys of different parts of the environment and ecosystems. Several different anthropogenic radionuclides have been analysed and found in almost all samples, whether terrestrial or marine. And this is just a summary of some recent work, and there are other marine studies that have found the same evidence of anthropogenic radionuclides in all types of samples. However, none of these studies have taken a historical perspective. The only ones that have used ice cores. So this means that we've got very little knowledge of the depositional history or the spatial variability in the sources of nuclear weapons fallout across the region, and virtually nothing is known for the subantarctic islands. Lakes occur throughout ice-free Antarctica and the subantarctic, and as sediments accumulate over time, it's possible to develop depositional history of contaminants in areas where monitoring conservation efforts are focused, including a look at the current status of contaminants in the environment and ecosystems, and so what that means for the future. We've looked at a lake sediment core from Macquarie Island, which is a small island off in the middle of the Southern Ocean between Tasmania, New Zealand and Antarctica. And we wanted to look at the following questions. Firstly, is there evidence of atmospheric nuclear weapons testing in the subantarctic? If so, what is the depositional history of anthropogenic radionuclides? What are the sources, and do they change over time? And are they still accumulating in the environment today? So Macquarie Island receives aerosols via atmospheric deposition as well as sea spray, and we're actually looking at these processes to get a better understanding of how they work and influence the water chemistry of Macquarie Island's lakes. And this is partly to do with developing paleoclimate records of the southern hemisphere westerly winds, but also lake water processes. And you can see a talk by Karina Meredith on Monday looking at the impacts of sea spray aerosols and water rock interactions in Macquarie Island's lakes. So we collected a sediment core from this small lake that you can see in the red box here. It's on the western edge of the plateau, and it's very small with a small shallow gradient catchment, which means that the majority of what goes into it comes from atmospheric deposition and sea spray as opposed to catchment runoff. The sediment core was 54 centimetres long and spanned about 2,000 years, and we just looked at the top 20 centimetres because based on lead-210 that represented the 20th century. We analysed for anthropogenic radionuclides using accelerated mass spectrometry at the Australian Nuclear Science and Technology Organisation, which has ultra-low detection limits for different plutonium and uranium isotopes. And this is what we found. So you can see that from the Macquarie Island core, there is a clear onset around about the 1940s, 1950s, a peak in the 1960s, and a decline since that point. If you look at this in relation to key dates, the start of atmospheric nuclear weapons testing was in 1945, undertaken by the states. The peak of testing was in the early 1960s, as you can see is reflected in the Macquarie Island core. The partial test ban treaty came in 1963, and main signatory nations were the US, the former USSR and the UK, and this banned nuclear weapons tests in the atmosphere but not underground. Key nations that didn't sign were France and China, and they actually conducted atmospheric tests into the latter part of the 20th century. Then in 1996, the Comprehensive Test Ban Treaty came into force. It's been signed by 186 nations, and that bans any form of nuclear weapons testing, whether in the atmosphere, underground or in the ocean. We also looked at different isotopic ratios of the different radionuclides. One of the most common ones is to look at the atom ratio between plutonium-240 and 239, which are the blue squares in the figure. We also looked at uranium-236 with plutonium-239, which are in the triangles. And the reason for looking at multiple different types of ratios is it can give you a better idea of changes in sources over time. But the main features of what we find is greater values in the 1950s, followed by a decrease in the 1960s. And I'm referring here to the blue squares, so the atom ratio between 240 plutonium and 239 plutonium. If we look at what that actually means historically, that's showing that in the case of Macquarie Island, most of what it's receiving is coming from US testing in the Pacific Proving Grounds, with some influence of testing from Australia. And this is because previous work has demonstrated that the higher values come from those tests, and you can see that in the figure down the bottom, which is just showing the total fission yield of different tests by different nations, and the blue ones are the states and the black ones are by Australia. Then if you look from the 1960s onwards, the global fallout is being dominated by the former USSR atmospheric testing, which you can see in green as a big green dot, and also in the figure underneath. What we've also found is that there's ongoing deposition on Macquarie Island. So the yellow squares illustrate the cumulative total plutonium concentration over time. And as you can see, that despite the fact that weapons testing has finished, there's still accumulation going on. And this is because these contaminants are up in the atmosphere circulating and depositing. You can see there are 1 to 2 peaks post 1980, and we're still looking into what they actually mean. One option is that it could just be a result of something happening in the core, such as a change in grain size. Another option is that it could actually be resuspension from a distant source and then deposition at Macquarie Island, for example from dust outbreaks or bushfires, which has been found in other studies. And this has implications for the future because these anthropogenic nuclides remain in the environment, and with projections of climate change, of more frequent and extreme events such as dust outbreaks and droughts, means that there may be more potential for these contaminants to reach remote regions of the subantarctic and the Antarctic. So just to summarise, this work has looked at for the first evidence of atmospheric nuclear weapons testing in the subantarctic. And what we found on Macquarie Island was the lake sediment record clearly shows the onset, peak and decrease in atmospheric nuclear weapons testing. Pre-1960s, the source of radionuclides is primarily from US testing in the Pacific Proving Grounds, with a lesser contribution from the UK in Australia. And then post-1960, the source of radionuclides is primarily from the former USSR tests in the Northern Hemisphere. What we also find is that there's evidence for ongoing deposition in the environment. And as for future work, we're analysing more lake sediment and peat cores from Macquarie Island to verify these results, and also subantarctic islands, with the overall aim of developing a circumhemispheric record of anthropogenic radionuclide deposition due to atmospheric nuclear weapons testing, and looking at changes in deposition and sources over time to get an idea of spatial variability. So thank you very much. If anyone's got any questions or comments, then please feel free to email me at the address you can see here. Thank you very much for listening.
Well, that was an extremely interesting talk, and I would encourage you, if you do have questions, please do get in touch with Christina, because I think that's something we don't really hear very much about, and it's important. We are now pretty much 5 minutes up, so if people would like to come back, and we will start the next session or part of the session in a few seconds. Okay, so I'd now like to kick off the next part with a talk from Marie-Charlotte Rumler from Think Jena, who is going to talk to us about monitoring of emperor penguins with drones, which is very topical, and I think something that we're going to be doing more of in the future. So, well, not just emperor penguins, but just generally using drones. But I'll hand you over to Marie-Charlotte now. Thank you.
I can't seem to be able to switch the monitor to the right one.
Does anyone have any thoughts on how we might help?
I think I know how to do it. I just can't reach it because of the Zoom window.
We have a minute or two.
You should be able to minimize the Zoom window, hopefully.
Yeah, I only have the small one already, but it's on a stupid place. Sorry, now I can. So
That's perfect.
I should be able to see the whole thing. Okay, sorry for the delay, and thank you for having me in this session. I want to start my presentation about my project by reminding us of some news or some information that we probably all have heard in the last recent years through one or the other channel, be it scientific platforms or maybe even the news, because it made quite an impact on media, which is maybe not really something to wonder about, because it's yeah, as it made the media, it's quite terrifying. Headlines like emperor penguins could be extinct by 2100 is quite worrisome, and the basis for those news is a series of modeling papers which was published in recent years, focusing on the projected changes in sea ice conditions, which is, as I guess most of us should know, the main breeding habitat for emperor penguins. And yeah, as you can see, most of the colonies will be extinct by the end of the century if we don't do anything. Many of them can be saved if we act now. So that is our part of the story, to act and to do something to protect the species from losing their habitat. But actually the penguins also might have a strategy or a solution to adapt to the problem. And this is something we observed in the last years, for example, at the emperor penguin colony at Antarctica Bay. Here on this map, you can see the usual position of the colony where it is usually situated. But in those years, we observed that they are also moving onto the ice shelf and forming colonies, or at least parts of the colonies there. Of course, this is only possible in some of the colonies, the ones which have those so-called ramps where they can actually reach the ice shelf. I don't think penguins will be able to adapt to climbing or flying up 20 or 15 meters of ice during the next 100 years. But there are still some questions remaining about those new habitats they are adapting to. For example, are they actually suitable for breeding? Do they give enough protection from weather, from wind, and so on? Or do they maybe imply a longer distance to the water, to feeding grounds, so that it takes longer to get to the chicks to feed them? Maybe ramps or crevasses on the ice are even unstable and propose some risk to mortality. So we need a lot more detailed information about what is happening here and about the dynamics of emperor penguin colonies. And one possible solution, which might be very good, are drones. And as has been already said, we are not the only ones that want to use drones for such scientific questions. But there are also increasingly tourists, filmmakers, private personnel that are using drones in Antarctica. And yeah, emperor penguins, majestic as they are, will not be an exception from this. So we did a study at Atka Bay, close to Neumayer Station, in Dronning Maudland again. And those were 3 main research questions that I want to talk about today. The first one is very basic question: are drones feasible to use them in such harsh conditions like the continental Antarctic? Is it possible to count emperor penguins effectively with drone imagery? And then, of course, the third, and for me personally most important question, how do the emperor penguins react to the drones? So what impact can we expect from activities with drones? Well, I guess those of us who had the honor of working in Antarctica, or at least in continental Antarctica, know a lot about the struggles that come with the weather, the climate, the conditions there. And those struggles become even a bit more amplified when using sensitive equipment like drones. Particular problem is keeping all the batteries and the power supply warm, because if they get cold, they lose a lot of their power, and then you will lose a lot of flight time. So, for example, we built this nice sledge with an insulated box on it to keep all our equipment nice and warm during the whole day. Of course, all the equipment you use must be suitable for the cold. So you have to see that all the cables, everything that's plastic, will all get brittle in the cold. And you have to find ways, or at least use equipment that's not so sensitive to cold. What we didn't expect too much is that also the bright conditions in Antarctica are a problem, because for drones, of course, you have to do a lot of monitoring and guiding. You have to use screens all the time, and it's really hard to look on a tablet or a laptop screen when the sun is so bright as it is in Antarctica. So we had to find solutions for that. As you can see, for example, in the picture with my colleague not sleeping under the jacket, but controlling the UAV. Of course, you have to be aware of the wind conditions, of the weather conditions. Fog, for example, can be a huge problem for drones. But if all those precautionary measures are taken into account and these issues are minded carefully, then we found that drones can be used really well in Antarctic conditions. So the second question was, is it possible to count emperor penguins from air? And this is basically what we did. We had our main emperor penguin colony close to the edge of the ice shelf. And then the second colony or sub-colony, which was the one that moved onto the ice shelf, on the left side, and we just flew transects over those colonies, taking pictures from above, and then mosaicing them later to count individual penguins. As we can see on this picture, they are actually visible quite well. This is a flight altitude of about 60 meters, so it's not that low. You can cover a relatively large area in a relatively short time. And what we found is that it's a lot easier to count them under sunny conditions. So if it's not too cloudy and the sun is really shining really bright, then you can see the shadows of the penguins, and that helps a lot with counting and identifying. And we also found that you quite well can distinguish between chicks and adults in the imagery. So shortly looking into our results, we found that there's the larger part of the colony is still on the sea ice, about 7,700 individuals, chicks, sorry, and 5,500 adults, and a bit less, as you can see in the table, on the shelf ice shelf. And also some skuas and Adelie penguins that we could detect from above. What we can also see is that the proportion of adults in the colony part on the sea ice is higher than the proportion of adults in the colony on the shelf. But the question remains, why is that? There's a different ratio, but this could have a lot of different reasons, and we don't know that yet. So it would be nice to look into that in more detail. Could be, for example, that just non-breeders are moving onto the ice shelf more often. Could be that there's a higher chick mortality, as we could kind of expect from weather conditions and so on, as I mentioned in the beginning. But we don't know that yet. So in general, we can say that drones are a pretty good tool to count emperor penguins. But there's much more data needed to investigate the colony dynamics when they move onto the shelf ice.
1 more minute.
Okay, sorry. So now I'm coming very fastly to the third research question, the actual impact of the drone. We did a lot of different experiments, vertical, horizontally, flights, human approaches, and those were all filmed with video cameras and analyzed in detail later. Those were our 4 main behavioral classes that we looked at. I want to present the results of vigilance and flipper flapping now. And I think this is our main result that we can see here, that the reaction of emperor penguins is rather short. So as you can see, it increases shortly after the UAV is directly overhead of the penguins, but then comes back to normal behavior quite fast in under 1 minute. And we can also see that it's only a very small percentage of individuals that even react to the drone. So the maximum reaction is at about 14 seconds after the drone flew over. Unfortunately, we couldn't find any threshold altitude where we can say that it's safe to fly with a drone. So all altitudes we tested up to 95 meters above the penguins still had a distinguishable behavioral reaction from controls or in comparison to controls. But we can see a trend that the reaction decreases with higher flight altitude. And to summarize the main results.
Start to wrap up now, please.
Sorry?
Start to wrap up now.
Yeah, that's my wrap up.
Thank you.
The main results from the other experiments were that chicks reacted more than adults. Vertical approaches had a higher impact than horizontal approaches. Fixed wing had a little bit less impact than a quadrocopter UAV, and humans imposed a higher impact than drones when reaching. So if you want to see more details about this, then please feel free to check our publications or email me or ask me later or now. And thank you for your attention.
Thanks very much, Marie-Charlotte. That was very interesting. I'm sorry we had to rush you at the end and for the technical difficulties. I'm afraid we don't have time for questions, but perhaps that you can be contacted directly. So I'd like to now move on to our next presenter, who is Christina Myers, who's from the Louisiana State University. And she's going to talk about carbon footprint of fieldwork, which I think is something that we will have to consider much more as time goes on, as we try to get to net zero. So over to you. Thank you.
Yeah, hi, thank you so much for having me. Do you see my the screen over here where my mouse is? Okay, wonderful. So yeah, my name is Krista Myers. I'm at Louisiana State University, and I'm part of the McMurdo Long-Term Ecological Research Project that's funded by the National Science Foundation, and we deployed onto Antarctica with the United States Antarctic Program. So today I'm going to be talking about addressing the carbon footprint of Antarctic fieldwork and moving towards more sustainable research practices in the McMurdo Dry Valleys. So this is our field site, the Dry Valleys. This is McMurdo Station here in East Antarctica on Ross Island, and we fly over to the Dry Valleys, primarily staying in Taylor Valley here, fly via helicopter. And this is a photo of Taylor Valley from the ground. So our group is about 30 scientists. It's very interdisciplinary, and each there's kind of subgroups that each have different specialties. So we have scientists studying the soils, the glaciers, lakes, streams, climate and weather. So we have a bunch of different people going down there, each with their different specialty, looking at the landscape from a different lens. And I've been down to Antarctica 6 times with the LTR, and I've noticed that, I've been having conversations with people across all disciplines and also outside of the McMurdo LTR that people feel kind of guilty about going down there and using a lot of resources, understanding, guessing that our carbon footprint is huge. So it's no surprise, for anyone on this call, it takes a lot of resources to do our science. So, flying down on Air Force planes, then doing our science on, for instance, on the lakes, we have to use a lot of diesel and gasoline to melt holes to retrieve our sensors. We're flying around in helicopters that are emitting a ton. We generate a lot of lab waste. And just even, living there, existing in Antarctica, it takes a lot of resources to heat the hut, melt our water, cook our food, etc., charge our laptops. So instead of just, feeling upset or confused about our impact, we started to ask these questions, how can we make our fieldwork more sustainable, and how can we reduce our carbon footprint? So that is how the McMurdo LTR Sustainability Committee was born. We're a really new group within the LTR, and we're less than a year old. So there's kind of 4 goals that I'm going to bring up today that we're trying to do within our committee. So we're just trying to expand awareness of the impacts of research activities on the Antarctic and the global environment. It comes back to the Antarctic Treaty and everything we've talked about. Being environmental stewards, I think also now should include looking at our environmental impact from a carbon standpoint, from a climate change standpoint. Second goal is to connect and empower scientists. I think it's really easy to feel helpless or, what can I do? So actually, connecting and coming up with solutions together. Third, we are scientists. Third, to estimate our emissions and resources, to quantify it. That's one of our goals. So I'll be presenting on that shortly. And then lastly, but most importantly, brainstorming ways to make our fieldwork more sustainable. So, okay, what now? What are we actually going to do? So here's our first stab at our emissions estimates for our field site for the McMurdo LTR. So this is a plot of data from 2002 to 2022. And on the y-axis, it's emissions in metric tons of CO2 equivalent. I have 3 different sectors here shown. Yellow is our plane round trip flight from the United States down to McMurdo. Then red is the helicopters that we fly around in once we're down there to reach all of our distant field sites. And then blue is the emissions related to one of our largest camps called Lake Horror that we have a few other camps, but we don't have a complete data set for those. So, and just for reference, I put here this black line. That's the average United States annual emissions. It's 16 metric tons of CO2 per year. Just to give you an idea of kind of like, is this a lot, is this little? But I'll keep in mind that this is the cumulative emissions for all, 30 some of our deployers. So breaking that down a little bit more by source and per capita, on average, 50% of our emissions are from helicopters, 45% from the planes, just getting to and from the ice. And then about 5%, and this is going on your research group. So whether you're, on a cruise or if you're in the, Willen's ice plain, your emission sources are going to look a lot different. Okay, so then per capita, on average, we calculated that the LTR emissions are about 8.3 metric tons per person per season. Once again, the US annual emissions is 16. Globally, it's about 4 metric tons per person per year. And according to the IPCC's, staying under the 2C warming, we really need to get down to 2 metric tons per person per year. So, if you tack on this 8, added to whatever your annual, back in the real world, whatever you're emitting, Antarctic researchers have a pretty big footprint, or at least the McMurdo LTR from what we've calculated. So before you freak out and say, oh no, like we shouldn't go down to Antarctica anymore because we're emitting too much, I will just put this into context or put it into perspective that so the LTR emits about 270 metric tons of CO2 per field season. Any soccer fans out there, the FIFA World Cup in Qatar 2022 will emit about 3.5 million metric tons of CO2. And so if we look at our one season one of our normal seasons compared to that, we're emitting about 0.008% of the emissions of the World Cup. So just to put it into perspective, humans are emitting a lot just going to soccer games even, let alone science. Okay, so what are we tackling first? We've quantified our emissions, we've made this group. We came up with, these are kind of 5, broad sectors that I'll touch on. So first, just trying to increase efficiency and collaborate more. We already do this, and I'm sure all research groups do this because time and resources are so limited in Antarctica. But I think also looking at efficiency through the lens of sustainability. So, joining helicopter flights together between 2 different groups, if we need to, plan ahead and make our schedules in a way that maybe we wouldn't overlap, but, then you plan on overlapping to be more efficient. Along those lines, so decreasing helo hours and just general resources that way. Kind of on the same thread, smarter maintenance schedules. So this year we're upgrading our weather stations. That's the group I'm in charge of. And we're going to have double the internal data storage capability. And also we're going to start to change our recalibration cycles so that basically we only have to visit every station every other year. So that will cut down, like right now we're visiting all 14 weather stations every year, but with this new data logger and this new calibration cycle, we're only going to have to go every other year. So that's 50% reduction in helo hours just for the weather stations. Reducing waste, so reducing lab waste, figuring out what we can and can't reuse when it comes to sample bottles, etc. Also around camp, just really making it part of our culture to be as sustainable as possible. Over here, prioritizing renewable energy sources and advocating for sustainable alternatives. So I can only really speak to the United States Antarctic Program, but for whatever you are requesting your support through, whatever channel or program that is, I encourage you to advocate for sustainable alternatives. For instance, with the United States Antarctic Program, I'm putting in our SIP, our request packet, that we want, renewables at camp, we want new technology to decrease our fuel usage. So being that squeaky wheel to get the grease, as they say. So, and then lastly, offsetting emissions for hard to decarbonize sectors. So that might be planes. So what you can't increase efficiency or reduce, such as the planes, we can take a hard look at who's going, how many people we need to go down, but we can't really control the emissions from the planes. So in that case, you might want to purchase some carbon offsets, but I have a huge disclaimer here. Carbon offsets are not all carbon offsets are not created equally. You really have to do your research, and it's kind of a rabbit hole. So I can talk about this offline probably for, half an hour if given the time, but basically, if you just go and Google the first carbon offset and pick the cheapest one you see, I bet my money that it's actually not sequestering carbon in the way that you would hope it would be. It's more likely to be paying back investors who may have provided some seed money for like a wind turbine project that was built 10 years ago or something. So we did offset our emissions going down to Antarctica this past year. It was our first year of carbon neutral travel. But instead of purchasing traditional carbon offsets, we donated money to this group called Honora. And they provide funding to projects that are actively sequestering carbon, that are creating new carbon sequestration projects, and are actively repairing natural ecosystems. And this is the most important part for me, while transparently measuring the amount of carbon being removed. So this is a really great group. I encourage you to look into them. These are the 3 groups that they are supporting. So, okay, so kind of in summary, if you're thinking, that you're inspired by this or whatnot, and you're wondering how to get started, there's no real recipe. We're a very new group, but this is the roadmap that we kind of ended up taking. So first, just start the conversation. Find your people within your research group, your university. Find the people that are interested. We have a group of about 14 of us in the McMurdo LTR that are on this sustainability committee. And a lot of them are grad students, actually. So there's a lot of youth interest. Then, second is to listen to the group. So our first meeting, we spent time creating this Jamboard, going over our shared goals and priorities for the committee. So it wasn't just one person telling the rest of the group what we're going to do. We really encouraged, and let everyone share their voice and their ideas for what they wanted to see in this committee and shape it. Step 3 is quantifying what you can. So that's what we did. We took all the data that from the historical camp usage, fuel usage data. You may or may not have this. You might have to do some back of the envelope calculations, but hey, that's, we're scientists, we're used to that. And then 4, this is the step that we're at, is brainstorming solutions. So, we're, like I showed those 5 kind of things that we're trying to tackle this year. This upcoming Tuesday, we're having our meeting, and our next meeting. And this is where we're going to be really going over these solutions and actually coming up with tangible ways of what we're going to do, who's going to do it, things that we can implement this season starting in October. And then share your ideas. So that's where I am right now, speaking to you, right? There's the best way to, rapidly get climate solutions is to not reinvent the wheel, right? So share your ideas, share what you're doing with other groups, and hopefully we can learn and, share successes and failures and know what works. Okay, so my calls to action for you. This is my challenge to everyone on this call. Just first start a conversation. So like I said, that's step 1. Just talk about sustainability with your lab, your university, your collaborators. Antarctic fieldwork is a very niche group, within the sustainability world. So you're probably gonna have to do some, come up with some solutions on your own. It's not like we can just go out and pick something off the that some city's doing or something. It's gonna be very specific. And then connect. So if you're already doing something to make your own research practices more sustainable, or if you're simply wanting to get involved, I'm gonna drop a Google form in the chat. Please fill out your information. I would love to hear from you. We want to, know what other people are up to. And I've already connected with a few researchers on this, and it's really inspiring. So please look in the chat and fill it out if you're interested in kind of getting together, or at least hearing from me about it in the future. So thank you so much. You are welcome to email me. I would love to hear from you. And thanks to the Sustainability Committee members and all of the support that we've received through the United States Antarctic Program. Thanks.
Wonderful. Thank you very much. We've probably got time for a very quick question. Does anyone on the panel or in the question and answers have anything they are asking? No. Can I ask you a question then? Because I think this is really important. And I think the only other example I can think of was done by Luis Pertiera on Byers Peninsula back in about 10 years ago. So it's really good to see this happening again. What I would like to know is, you have an environmental impact assessment undertaken for all of the activities that are being done in Antarctica. And I'm wondering, are you talking to that team about what you're doing to see if they're thinking similarly? I think Polly Penhill is the person in the US who coordinates that.
Yeah, we have not coordinated with them. They know that we're doing this, and we've asked for some data, and they haven't they haven't compiled the data as far as I know. But that's definitely our next step, is to sort of make those connections with the USAP Environmental Network. They know that we're doing this, and we've even collaborated with Antarctic New Zealand a little bit, just getting their perspective on it too. So that's definitely the next step, is to take this just beyond our group. But for now, yeah, it's only been, we've been around for, about 6 months. So hoping to make it broader though, for sure.
Well, that's excellent. I wish you all success, and I hope you grow and become international, because it's really important.
Oh yeah, and I mean, I just put the form in the chat. Please fill it out if you're interested. It's just, your name, your email, and then if you're doing something, we would love to hear what everyone's up to and get ideas, and hopefully, yeah, create something, some sort of network where we can share.
Perfect. Thank you. Okay, so just like to move on to our last speaker, Jasmine Lee from British Antarctic Survey, who's going to talk about state of the Antarctic environment reporting. Over to you, Jasmine.
All right, I think you should have my screen now. Perfect. Right, so thanks for all of you being here to listen to a session of what has been some really fascinating talks. We're going to finish up by talking about an idea for an Antarcon project, and that is about state of the Antarctic environment. So this is a research theme too, the human impacts theme, like project led, and it's something that Kevin, Andy, and myself have been thinking quite a lot about in the last couple of months. So at the moment, it's still really in the ideas phase, so we are really keen to hear all of your feedback. So, as we all know, Antarctica is considered a pristine nature reserve dedicated to peace and science and free from the impacts of humanity that threaten the rest of the globe. Unfortunately, and as we've heard from some of the talks in this session, that is not necessarily the case. Antarctica and its unique biodiversity are under pressure from multiple threats. So these include human activities themselves, so our science and tourism, local and long distance pollution, extractive activities such as fishing, invasive species that are predicted to get worse with warming, and of course, climate change itself, which will have a series of direct and indirect impacts on the environment and the species that live there. So considering all of these multiple threats leads to the question of how much do we really understand about the impact these threats are having on the environment, and whether this information is available to decision makers. So as we heard in the Antarcon mini symposium yesterday, Antarctic policymakers rely heavily on scientific information to inform their decisions. So indeed, state of the environment reporting was considered important enough to be built into the CEP's functions. So the Protocol on Environmental Protection to the Antarctic Treaty of the Antarctic Treaty, or the Environment Protocol for short, is the primary legal instrument protecting the Antarctic environment and laying out the basic principles for parties to follow for human activities in Antarctica. The Committee on Environmental Protection, or CEP, was established as the expert body to provide advice and recommendations to the Antarctic Treaty Consultative Meeting on matters relating to the implementation of the protocol. So Article 12 of the protocol considers the functions of the CEP, and it specifically highlights the need for the CEP to provide advice on the state of the Antarctic environment to the ATCM. So whilst providing advice on the state of Antarctic environment is one of the CEP's roles, there has generally not been an ongoing attempt to do so. But that is not to say there have been no attempts. So what has been done before? So this is just to say quickly, this is not a comprehensive summary, it's just some examples of what has been done. So New Zealand led an early process on state of environment reporting for the Ross Sea region, submitting a working paper to the ATCM and producing a nice report. And several years later, a CEP working group was established to further work in the area. And they even developed a web system for state of the Antarctic environment reporting for kind of routine reporting on key environmental indicators. Unfortunately, though, this did not appear to persist. Australia has also included Antarctica in its national state of the environment reporting since 2004, with the most recent assessment coming out just several weeks ago in July. So this assessment focuses on the East Antarctic, just as the New Zealand assessment focused on the Ross Sea region. So there has been some reporting done for specific regions in Antarctica, though less for the continent as a whole. What's important to note here, really important to note, is that the state of environment reporting or assessments can be many different things to many different groups. So this could be changing focus, changing topics, changing details that are included. And each of these is something that has to be considered when thinking about the best way to undertake a state of environment assessment. So this leads us to the idea we are pitching today, and that is to harness the anti-icon community's expertise to help inform state of Antarctic environment reporting. We recognise that this is a task for the wider SCAR community, not just Antarcticon, but we imagine that lots of groups will be interested in being involved, including the Action Group on Plastics and Polar Environments, ICE, Integrating Climate Ecosystem Dynamics, MESO, the Marine Ecosystem Assessment of the Southern Ocean, and of course ANTOS, the Antarctic Nearshore and Terrestrial Observation System, ZEUS, and the Action Group on Pollution Impact. So I think there's lots of expertise out there. And so hopefully this means that we could potentially put together something really informative. While we think about this, it's also important to recognize that there are a number of limitations on what we can realistically achieve as a SCAR community. So on the positive side, we have a really large community, as we've just highlighted. We've got a wide range of expertise across a huge range of kind of topics. We've got really willing and passionate members, as we've seen through the organization of this conference and all the groups that are ongoing. However, we do have some limitations. We have very limited financial resources, which is a big one, and that's something that's been highlighted a number of times tonight already. And we rely on volunteers. And though they are willing and passionate, we've also got limited time, and it's important to recognize that. We've also got a requirement to kind of remain objective and impartial, which I think SCAR does pretty well, but we've always got to keep that in mind. So, with considering everything, this is what we are thinking about the plan, how this project could be undertaken. The first step would be to hold some Antarcticon community workshops to kind of undertake a whole bunch of decisions and really think about the best way to implement this project. Follow this up with some more targeted stakeholder engagement with, for example, the CEP. Work with SCATs to potentially present a working paper to the CEP and ATCM next year with a proposal of the plan and kind of give them a final chance for a nod of agreement and or further changes. And finally, to move forward with the community to achieve the agreed objectives. So when we're talking about some of the decisions that we need to make as a community, we need to consider who will be the intended recipient. Is this a CEP in CAMLA, or is this kind of a more global recipient? What form should the output take? Of course, it could be a report, it could be working papers or information papers, or potentially should it be a kind of web-based internet system? How should we communicate this? This kind of comes down in the same way. What length, what platform do we use? At this point, we're thinking we should consider the marine and terrestrial environment, but whether that's possible or not, of course, depends on the community. We've also got to consider the topics, which I'll speak briefly about after this, how we break down the regions. So you can see here on the right-hand side, 2 examples of regions we could use for the marine and terrestrial environment. That is the SUE's regional working groups, and you can see they've split the marine system down into about 7 regions. And so that might work really well. We've also got MESO regions that could potentially work. And then for the bioregions, there's 16 there for the terrestrial system, and we're thinking that's a bit too many. So we will need to carefully balance the need for being able to kind of contrast between different regions, recognizing that impacts are not the same in different regions, and also be able to not have so many that it's kind of a hindrance to us. And we also need to consider the breadth and depth of how much information we want to provide for each of these regions. Now, I'll just talk very quickly about topics. And so the thoughts that we had was for each of the regions that we break it down into, we then want to kind of assess the state of Antarctic environment on different kind of threatening processes or topics. So there's a whole range of these, as we kind of mentioned. There's non-native species, there's pollution, there's human activities, etc. How broad these should be is a huge question. Should we consider them just like that and there's kind of 4 categories, or should we break it down further? You know, there's marine and terrestrial non-native species. Should we consider whether they're human assisted or whether they've arrived by their own means? Should we break, you know, local pollution down into oil spills, plastics and sewage, or should we just consider them all together? And finally, with climate change, we would like to recognise a lot of work has already been done in this area, especially noting the recent Antarctic climate change and the environment reports, which was the most recent one was presented to the ATCM earlier this year. And we don't want to be duplicating work that has already been done or is ongoing. So instead, we want to be able to produce something that's complementary to these initiatives and that can be used together. So we recognise climate change will have a huge impact on all of these things together. And this is definitely something we can consider the synergies between them and how climate change will further impact each of these threats. For example, we know it's going to have a large impact on prevalence of non-native species. So this basically highlights that there's a lot of things that still need to be considered and decisions need to be made before the project can get underway, which is why we are really excited to start spreading the idea through the community and start planning. So please let us know what you think and watch this space for some announcements about workshops. And with that, I'd like to say thank you very much, and please fire away with questions. Of course, Andy and Kevin are both here as well, so can help with answering. Thanks.
Well, thank you very much, Jasmine. Obviously, Andy and I are part of that talk, so we're not necessarily going to ask any questions, but just to repeat that, I think, yeah, workshops and consultation are absolutely essential for this to work, and not just with the science community, but I think we need to be talking to the policymakers, to the members of the CEP, potentially even CAMLAR, to see what they want and what is useful that fulfills their requirements. So completely agree, Jasmine, that's a big part of this. I'm just wondering if there's any questions, Andy, in the questions and answers, or?
No, there's nothing come up, so I think we can take that as resounding support.
Hooray! Excellent. It is getting well. It's getting late here. I don't know what it's like around the rest of the world, but we're coming towards the end of the session. So if there are no particular questions, then I will start to wrap up. Firstly, just to absolutely thank all of the speakers for their excellent presentations. Also to thank those who've done posters. I think I would, again, just heartily recommend that you go across and have a look at them. There's some really excellent work there. Just to say, tonight we've heard about lots of really good research, which is for the good of Antarctica, to enhance our protection of that continent, to try and look at some of the impacts and see what we can hopefully do to minimize those in the future. So it's good to see. We need more of this sort of thing. So keep going is kind of my message to everyone. I think with that, I don't think I've got anything else that I need to announce. Anything from you, Jasmine or Andy?
No, nothing.
Shakes of the head. Okay, well, with that, I will say thank you very much. And again, thank you to our IT support team who've been fantastic. And I look forward to seeing lots more exciting research come to the next Open Science Conference and to read it in the literature. So thank you very much indeed. And good night, everyone. Thank you.
Thank you. Bye.
Thanks, everyone.
Bye, everyone. Thank you.
Thank you. I think we can probably stop the recording now.